Now we can start the simultaneous game concepts. It's very much self-explained actually. The players makes their decisions simultaneously. But that doesn't have to be exact timing. Instead the rule is, players don't have any information about other players' decisions. So, while they are making their choices, they don't have any information about how others will play. In these type of games, the solution is the Nash equilibrium. In simultaneous games, strategies can be pure or mixed. Mixed strategies are based on probability. It's like 50% left, 50% right. There is no certainty. And the choices can be discrete, as well as continuous. For instance, left or right are discrete choices, and price is continuous. You can decide wherever you want between $100 and $500. Important point. Simultaneous games are usually represented with normal forms. What is normal form? Well here, an example of normal form of rock paper scissors game. In two players games, like this one, each cell represents the payoffs for both players. Let me show with pointer. Here, each row represents the player 1's choices. If player 1 decides to play rock, we can see the possible outcomes in the first row. If player 1 plays paper, you can see it in the second row. Again, each cell represents the payoffs for both players. So let's look at this cell. It says 00. First number is the outcome for first player and the second number is the outcome for the second player. So here they both get 0 points. Check this one, this cell will be executed if player 1 chooses rock and player 2 chooses paper. And the outcomes are -1 for player 1, and 1 for player 2. And it makes sense, because paper beats rock, so the second player wins the game. Okay, as I mentioned, each row represents the choices of player 1, and each column represents the choices of player 2.